Hi, welcome everyone, and thank you for attending. My name is Neville Chaporia, Senior Director of SSD Marketing and Product Management at KIOXIA America. Today, I'm going to talk about how PCIe 4.0 SSDs can improve scalability and application performance within the data center. Before we dive in, here's a brief introduction of who we are. Remember, Toshiba Memory is now KIOXIA, a leading worldwide supplier of flash memory and solid-state drives. What does KIOXIA do? We are memory. We're SSDs. We are innovators. From UFS to eMMC to custom NAND solutions, from client SSDs to enterprise SSDs to data center SSDs, we design and build it all. According to analysts, KIOXIA commands roughly 17% share of the overall NAND flash market. KIOXIA also owns and operates the world's largest flash memory plant in Yokkaichi, Japan. The newest addition to this facility, Y6, is operational today. We will also break ground on a new fab called K1 in northern Japan that will deliver the latest generation of BiCS flash memory technology to support the growing demand for NAND flash products. KIOXIA boasts one of the industry's broadest line of SSDs encompassing client, data center, and enterprise segments. We are vertically integrated with in-house SoC and firmware capability. Some of the world's largest corporations depend on us for their flash memory and SSD needs, and we are trusted by the top 10 server and storage vendors today. KIOXIA was the fastest growing storage vendor a few years ago, and recently, as part of our Life After SATA campaign, we were first to market with a value SaaS product line. Innovation is in our DNA. In 1987, we invented flash memory. In 1991, we brought to market the world's first mass-produced NAND flash memory. In 2007, we announced the world's first 3D NAND flash memory. In 2017, we introduced KumoScale, our NVMe over Fabric software solution for data centers. And here we are in 2020. We've introduced the world's first PCIe 4.0 U.3 SSDs, and we're only getting started. One of the fundamental and consistent characteristics of compute, networking, and storage technologies over the past few decades has been the promise of delivering more performance than the prior generation. And this improvement in performance at scale now powers today's massive data centers and enables migration of new, more complex applications to the cloud that were deemed practically unthinkable just a couple of years ago. So let's take a look at what's driving the need for speed in the data center environment today. First, next generation applications such as artificial intelligence, machine learning, containerization, and high-def 4K and 8K content streaming are moving to the cloud. These applications are very data intensive and drive the need for much higher performance at scale. Second, a new generation of processor technologies, including massively parallel GPUs and CPUs, FPGAs, and tensor processing units, are bringing a whole new level of performance to address the unique challenges that applications such as deep learning and machine learning bring to the table. Third, newer and faster networking technologies with extremely high link speeds of 200 and 400 gigabit Ethernet and even faster speeds on the horizon as 5G deployment goes mainstream are unlocking traditional data bottlenecks and enabling the internal plumbing within data centers, the spine and the super spine links, to carry the exponential increases in data traffic year after year. The natural consequences of the commercial availability and convergence of these three technologies is driving the need for a data-centric server architecture that is high performance and bandwidth, low latency, and scalable network connectivity. In order to realize this objective, data-centric server architectures require high-performance storage so they can access, analyze, and manage more data in real time. This is where next-generation SSDs performance becomes more important. SSDs are by far the storage solution of choice in high-performance servers today. By improving the bandwidth at the front end, SSDs can unleash the performance of NAND flash technology available at the back end, dramatically increasing a server's data handling capacity and ensuring that the storage is not the bottleneck for next-gen applications. Enter PCIe 4.0. Now that we, as an industry, have moved NAND flash to a flash-optimized protocol in NVMe, PCIe 4.0 delivers up to 12 times the performance of a SATA SSD and more than twice the performance of a PCIe 3.0 NVMe SSD available in the market today. PCIe 4.0 is therefore uniquely suited for high-performance cloud server applications as it doubles the server's data handling capacity. Now let's take a look at how PCIe 4.0 adoption is likely to play out in a few critical markets. While some early adopters across a number of markets were playing with PCIe 4.0 last year, we see the server market moving into mass adoption first in 2020. A number of processors, host bus adapters, and RAID adapters are coming to market and will support PCIe 4.0. Next to adopt, we predict, will be client PCs. Initially, workstations and gaming PCs will drive PCIe 4.0 adoption, but starting in 2021, we expect mainstream adoption of PCIe 4.0 SSDs across notebooks, desktops, and workstations. Finally, we anticipate the storage market will transition to mass adoption with PCIe 4.0 between 2022 and 2023, as the rigorous testing cycles and complex development activities associated with storage arrays will require a little more time to make this transition. PCIe 4.0 will also be the impetus for migration to new form factors as applications seek more power, more capacity, or cooling capability in an ever-shrinking footprint. KIOXIA was the first to announce and publicly demonstrate PCIe 4.0 NVMe SSDs at the Flash Memory Summit last year. Our PCIe 4.0 SSD lineup now includes two products, CM6 and CD6. CM6 is optimized for high-performance server applications such as compute-centric AI and ML, and CD6 is optimized for general-purpose server applications such as media and content streaming. Both series use KIOXIA's 96-layer BiCS-Flash 3D technology, are compliant with the NVMe 1.4 specification, support 2.5-inch and EDSFF form factors, and are available in 1 and 3 drive write per day endurance options. Collectively, both these PCIe SSD series can address a wide variety of high-performance application workloads. The PCIe 4.0 value proposition isn't limited to bandwidth alone. It also translates to improvements in overall I/O performance and latencies. To demonstrate this, we compared all three metrics between KIOXIA's PCIe 4.0 CM6 series and the prior generation PCIe 3.0 CM5 series. Across the board, the PCIe 4.0 CM6 demonstrated much better throughput and response time compared to the PCIe 3.0 SSD. In some corners, this improvement is quite significant. While read performance roughly doubles, the improvement is even more pronounced on writes, with random writes increasing by a factor of 5x and write latency improving by almost 60% or more. This improvement in write performance on PCIe 4.0 has a profound effect on real-world database workloads. In fact, if you head on over to our virtual booth, KIOXIA will demonstrate how PCIe 4.0 can improve your database performance. Our demo setup includes a QCD server sporting an AMD EPYC 64-core CPU, 128 gigs of DRAM, and two KIOXIA CM6 SSDs running MySQL and a database benchmark like HammerDB or something similar, the results of this benchmark are impressive. So go check out the video demo at our virtual booth. The bottom line is you should expect, at a minimum, a 30 to 40% improvement in transactions per minute for this given benchmark. Now, a large majority of cloud applications typically translate to read-intensive workloads at the storage level. So it comes as no surprise that PCIe 4.0 also improves overall read performance. Here's another demo you can check out at our virtual booth. We've got a Supermicro PCIe 4.0 enabled server with an AMD EPYC 24-core CPU, 128 gigs of DRAM, and a KIOXIA CD6 SSD running Ubuntu and an FIO benchmark. We then measured both large block, as in 128K, and 4K block read IOPS and bandwidth. The results are pretty impressive here as well. So on the left-hand side, as you can see, the PCIe 4.0 SSD performance for both large block sequential read IOPS and read bandwidth is roughly twice that of the PCIe 3.0 SSD performance. Similarly, on the right-hand side, the PCIe 4.0 SSD performance for both 4K block sequential read IOPS and read bandwidth is more than 3 times that of PCIe 3.0 SSD performance. As with the previous example, in real-world applications, this translates to a profound performance improvement on workloads such as those used in Object Store, enabling the SSD to handle twice the amount of data streams that the prior generation of PCIe SSDs use. Again, check out our virtual booth. We have another demo showcasing the performance of PCIe 4.0 for content streaming purposes. We will also highlight SAIO, or Swift All-in-One use case. SAIO, as some of you may be aware, is a workload often associated with CDN use cases, or Content Delivery Network use cases. In summary, next-gen applications are driving ever-increasing data-intensive workloads and subsequently are driving the need for high-performance storage. PCIe 4.0 technology eases I/O bottlenecks by doubling the PCIe interconnect speed and paves the way for improvements in resource efficiency, node scaling, and overall system performance. Stop by KIOXIA's virtual booth for more information on our PCIe 4.0 products, data sheets, demos, and check out our cool videos. Thanks for watching and have a great day.